All right, let's talk about position time graphs. So first off is the question of what is a position time graph? It is a graph that shows an object's position as a function of time. This means that position, which will always be on the y-axis, is represented on the graph as a point or as part of a line in relation to the amount of time that has passed since the object started moving. And time will always be on the x-axis. So if I have this example of this little car driving, it starts driving at 0, 0, time 0, position 0, and then after 1 second, it's moved 10 meters, 2 seconds 20, 3 seconds 30, etc. This is what the position time graph would look like. This graph can be used to determine an object's displacement over a given period of time. So if I want to say where is the object after 4 seconds, I can just look at the graph and say, okay, it has moved a total of 40 meters. And we'll get into using our displacement equation to figure out displacement as well. So if I was to look at this graph, calculating the distance and the displacement, what is the distance and displacement of an object from point A to point B? Well, point A is 20, point B here is at 3. I know from my y-axis that the unit is meters. So if I wanted to find my distance, I would say, okay, if it started at 20 and it went down to 3, then it went a total of 17 meters. If I was going to find my displacement, I would have my final position, which is 3, minus my initial position, which is 20. So I would get negative 17 meters. Now again, because it's only moved in one direction from point A to point B, the numerical value of my distance and my displacement is identical. We just have that negative sign there for displacement to show that it went in a that my graph moved in a downward direction or moved away from my starting point. If I wanted to do a displacement from B to C, okay, I start at 3 and it goes up to 15. Well, that's a change of 12, so my distance would be 12. And to find my displacement, I would do 15, because that's the final position, minus 3, which would also, again, be 12. Take a minute to see if you can calculate what the displacement would be. You can go ahead and pause the video and see if you can get the displacement from A to C. All right, you should have had that the distance would be 29 meters because we went a total of 17 and then a total of 12, so that's 29 meters total. And then for my displacement, my final position is 15, my initial position was 20, so 15 minus 20 gives me negative 5. So that's how we can go about and find distance and displacement using a position time graph. Having the y-axis here makes it really easy to use the equation. You can also even just, if you didn't want to do the math out, you could actually just count how many lines, as long as you know what the scale is, figure out how many positions it has moved in between. So just with counting, I could do 3 and I would see that I went up. If I start here at 3, I go up 12 to get to that position. Every type of motion has a particular type of slope on these graphs. Now we're only dealing with linear motion while we're doing this, and we're not dealing with velocity or acceleration, so we're always going to be at a constant speed for our purposes. Once you get into higher level physics, then you will get into you'll have more different types of slopes, and you'll also have acceleration, so you'll have curved lines. For our purposes, all of the lines will be straight. And by straight, I mean in between 2 points. So if you have a line with a positive slope, then that means that the object is moving at a constant speed in a positive direction or moving forward. If you have a line that has a negative slope, that means it's moving at a constant speed in a negative direction or moving backwards. And then this is the one that's the hardest to imagine, but we have to remember that our x-axis is time. If an object is not moving at all, then we would expect to see a straight horizontal line, because that means that as time is passing, they have not moved their position. So horizontal segment means that the object is at rest. No matter what kind of motion is happening, the line will always move to the right because time is always moving forward. So you'll never have a line, you will never see a line that will start here and then go up and then go backwards. You can't go backwards in time. So no matter what, the line will always be moving forward on the x-axis. Okay. Slope can also be used to help us think about relative speed. The steeper the slope, the faster they're moving. Again, if you think about that, that makes much more sense. With this person or this object, they started at 5 and they get up to 9 over the course of 20 seconds. So they have a relatively shallow slope, right? It's close to horizontal, so they moved 4 meters in 20 seconds. Versus this slope, which is definitely steeper, they started at 10 and they get all the way up to 20 in the 20 seconds, which means that they moved 10 meters in 20 seconds. So the more vertical your slope is, the faster the object is moving. All right, other information that we can get when we look at our x-axis, when we're looking at time, where the object is located, we are able to get. So if I wanted to know where the object was at time 10 seconds, I'm going to find 10 seconds on my x-axis and then go up until I reach the line. And that tells me that it was at 12 meters. Another thing I could do is how long does the object move away from its starting point. So if this is the starting point, from between A and B, it's moving away, and that's 4 seconds. From B to C, it's moving back towards its starting point, so we're not going to include that. And then C to D, it's once again moving away from time 12 to 20, so 8 seconds. So the total amount of time it is moving away from its starting point, the 2 times it has a negative slope, is a total of 12 seconds. Take a second and see if you can calculate this. How long does it take the object to move a total of 20 meters? So the distance from A to B is 17. And then we want to know what 3 meters is after that. So we got 17, 18, 19, 20. And we can look and see that that is at, is at 6 seconds. Is when the object moved a total of 20 meters. So again, remembering that it's distance, not displacement here. In no case do we have a displacement of 20 because it never gets all the way down to 0. All right, take a minute and see if you can answer these 3 questions. When is Marie driving the fastest? Between which points was Marie stopped? How does her speed at 3 minutes compare to her speed at 7 minutes? How far away is Maria's work from her house? And what happens in the last, what happens at minute 5? So take a second, pause the video, see if you can answer these. Okay, when is Maria driving the fastest? She is driving the fastest from point E to F. We know this because it is the steepest slope. It's steeper than A to B or B to C. When, between which points are they stopped? D to E. We know that because it is a horizontal line. How does the speed at 3 minutes compare to the speed at 7 minutes? So if this is about 3 minutes right in here and this is 7, the slope of these 2 lines is identical. That means that they're moving the exact same speed. How far away is Maria's work from her house? Now this one is where we're going to use displacement, not distance, because they turn around and they stop for a while, so we can't use the total distance, but we can go from point A, 0, to the final point, F, 20. So 20 minus 0 means that their house is 20 miles away. And then the last question was what happened at minute 5. Minute 5 is when they turned around and changed direction. So they were going towards work, then went back home. So point B is where they changed direction. And that is how you can calculate different things on the position time graph.